real-life application we have for working with polynomials is to find missing dimensions for volumes of prisms and cylinders and so on. So in this case, we're given a rectangular prism and we don't know the dimensions of it. All the sides are unknown to us, but we do know what the volume is. And so because volume is 3 dimensions, we're going to have 3 things we're multiplying together, hence our polynomial. And so what I've done is I've already gone ahead and written my equation to find the volume of a prism. Recall it's length times width times height. So 2x times x minus 4 times x minus 1, and I want to set that equal to my volume of 40. Now what I'm going to do is I'm going to use my graphing calculator to solve this problem. I'm not going to try to do this by hand. And so to solve by graphing, I've gone ahead and already entered in one side of my equation as y1, and I've entered the other side in as y2. And what I want to do is find the intersection between the polynomial, which is y1, and the line, which is representing my volume of 40. And so what I'll need to do is I'll have to adjust my window because I'm not going to see what I want to see. I know that my y max, the high point of my graph, needs to go at least up to 40 because the line y equals 40 is a horizontal line 40 spaces up. So go something above 40, I chose 50, and then I left, or actually I changed my y mins as well and my x mins. So y min, y represented volume, so I knew I couldn't have a volume of 0. And x represented the dimensions of the box, the side lengths. So again, I knew that that couldn't be negative, so I used 0. I didn't know if 10 would be big enough, so I just stuck with 10, and I knew if I saw an intersection, it was good, and if I didn't, I'd have to adjust it. So that's why I chose the window I used. There's the polynomial representing the different dimensions of the box if x changes, and there's when the volume is equal to 40. And so I can see the intersection that I want. If I couldn't see that, I'd have to adjust my window, but I see what I need. So from there, I've selected intersect from the trace menu, from the calculate menu. So second trace, select option 5, and we just want to arrow over close to it. Ironically, it lands right on it, but whatever, we didn't know that. So go ahead and press enter 3 times to answer the 3 questions about first curve, second curve, and guess. And it'll tell me the intersection is going to occur when x is equal to 5. And so the possible value of x is that x is going to be 5 to get me the volume that I want. I went ahead and also found the dimensions of the box because sometimes they ask about that. And so I plugged in 5 for each of my x values. And so 5 minus 1 is 4. 5 times 2 is 10, and then 5 minus 4 is 1. And that makes a really easy way to check too. 4 times 10 times 1 is of course 40 for my volume.